In match problem 4, we're still going to be taking advantage of the power rule function, but now we're also going to be mixing in with that the constant multiple property. So in each of these cases, if we're taking the derivative of 4x to the fifth, where again this f prime notation d over dx means the same thing, so just writing this a little bit differently. 4 is just a constant multiple, so we can rewrite this as 4 times d over dx, or the derivative of x to the fifth power. So we want to do that because 4 times x to the fifth isn't exactly a power function by itself, but because of this constant multiple property, we can pull that constant out in front of the derivative and evaluate this as just 4 times 5 x to the fourth, or 20 x to the fourth. Now, as you start to become more comfortable with these different steps, you don't necessarily have to actually take this intermediate step of rewriting the problem. But here I'm going to keep doing it in each of these examples just to show where this idea is coming from. In our second example, we're taking the derivative of t to the fourth over 12, which if we wrote that a little bit differently, would be the derivative of 1 over 12 times t to the fourth power. So the trick with these is realizing that that 12 in the denominator is really just a constant multiple of 1/12, which means we can rewrite this as 1 over 12 times the derivative of t to the fourth, which will be 1/12 times 4 t to the third, which will simplify to t cubed over 3. Since 4 will divide into 4, and 4 will divide into 12, leaving us with 3 left over. So just reducing there at the end. In part C, we have a similar problem. We're taking the derivative of 1 over 3x cubed, which is the same thing as the derivative of 1/3 times 1 over x cubed. So we can bring that constant multiple outside the derivative, and instead of writing this as 1 over x cubed, we can rewrite this as x to the negative third power, and again, we can apply that power rule. So this derivative will be 1/3 times negative 3 x to the negative 4, and then negative 3 over 3 will cancel, leaving us with just negative 1, so negative x to the negative fourth. In part D, again, we can rewrite this as the derivative of 0.9 times 1 over the cube root of x. 0.9 is our constant multiple, so we can pull that out in front of our derivative. And 1 over the cube root of x is the same thing as x to the negative 1/3 power, which will give us 0.9 times negative 1/3 x to the negative 4/3, and then multiplying 0.9 times negative 1/3 will give us negative 0.3 x to the negative 4/3.